Nice to meet you. First, I will summarize the weekly learning content before we begin. This is session 4. Today, I will explain about self-holding circuits. In the first session of week 4, we will be covering self-holding circuits. I am Professor Kim Dae-kyung, in charge of this lecture. Let me explain the structure of the first session's content for week 4. First, I plan to explain the structure of the self-holding circuit. Next, I will explain the wiring connections of the self-holding circuit. The next part will cover the educational objectives for the first session of this week. The first educational objective is to be able to explain the structure of the self-holding circuit. You will be able to explain the operating principle of the self-holding circuit, also known as the self-hold circuit. 2. You will be able to connect the wiring in the self-holding circuit. With these 3 educational objectives, we will proceed with the first session of week 4. In Chapter 1, Week 4, Session 1, we'll cover the self-holding circuit. Let me explain the content of the lecture. Let's review the content of the Week 4 lecture. First, let's talk about the push-button switch, which has been mentioned continuously. As mentioned earlier, various electrical and electronic circuits are composed of switches. So as long as you understand how to use those switches and are familiar with those aspects, that will be sufficient. A representative example is the A contact and B contact. And in connection with that, the second point is understanding the A and B contacts inside the relay. Specifically, whether they are normally open or normally closed, that is, whether they are NO or NC. It is important to clearly distinguish these aspects. Next, let's talk about the relay socket that we will be using directly. Previously, I already explained the operating principle of electric relays. I also discussed how to connect and wire an electric relay to a socket, and it's important that you are able to do this properly. Additionally, as we have continuously discussed, it is necessary to have a good understanding of the differences between AC, that is alternating current, and DC, direct current, when making connections. And now let's talk about the wiring method. So I will explain how the contact point numbers are indicated and how to check the connections. To check the contact connections, you use a multimeter to identify shorted sections, and by inspecting the circuit in this way, you can generally confirm which parts are connected by the beep sound from the continuity test. And finally, when making wires, I will talk about what you need to pay attention to and also what you should be careful about during wiring. It's important to make sure that there are no shorts or unintended contact with other parts, so you need to be careful about these aspects when wiring. The diagram here is a physical wiring diagram. It's also called a double line diagram. This refers to indicating every single wire exactly as it will be installed in the actual work. When carrying out construction, this kind of physical double line diagram is very useful for accurately calculating things like the number and length of wires that go into the conduit, or the amount of materials needed for the job and for making estimates. As you can see here, there is a terminal block that can be connected. From the terminal block, each wire is drawn out, passes through this type of modular terminal block, and it is indicated here how and to which pin it is connected in the socket. Here, the red light, green light, and yellow light lamps are shown, and the push button is indicated here as well. The parts marked in the middle are relay terminals, so it shows how the relays are to be connected and similar details. Now let's take a look at an example of drawing a wiring diagram as part of the sequence control work. You need to take a close look at the circuit section on the left. If you look at the circuit section on the left, you can see that power is supplied with 24 volts DC, and then the power is connected to 0 volts DC. Then, as you can see here, the start button is a push button, and the start buttons are connected in series. The stop button is connected as a normally closed B contact, and the start button is connected as a normally open A contact. So there are 3 push buttons like this, 1, 2, 3, and you need to check which part will be used. For example, with the start button, it is normally open. So if the power supply is connected on this side, it should be connected like this. And since this part and this part are connected in a normally open state, we can indicate that the part on the left is now connected. Then the 24 volts DC comes in, gets connected like this, and is connected as normally open with one wire coming out. Now, the wire that comes out needs to be connected to the stop button. And as you can see here, the stop button is a normally closed contact type. So since it is normally closed, you should use the normally closed part. So if you were to label them, this would be the start button. And this would be the stop button. Since the stop button needs to be indicated as a normally closed contact, it should be connected directly in the normal closed state. So you just need to connect this part like this. And the next part to be connected should now be connected to the relay here. So it gets connected to terminals 14 and 13, which are the negative parts of the relay. Then, since one side of the stop button should be connected to terminal 14, you can connect it to the positive like this. And finally, since terminal 13 is connected to 0 volts, if you bring the 0 volt connection over like this and connect it, the entire line on the far left will be completely connected. So to summarize once again, the 24 volts comes in and is connected to the normally open A contact like this. And one side of the A contact goes out and connects to the normally closed B contact. And one end of the B contact is connected to the relay's positive terminal like this, which is then connected to terminal 14, the positive terminal. And terminal 13 comes out and is connected to 0 volts like this. Here, the terminal marked with a plus sign indicates the 24 volts DC part. The terminal marked with a minus sign indicates the 0 volts DC part. It's connected to the left like this. On the right side, the part for the self-holding circuit is set to terminals 5 and 9 of K1, and terminal 5 is connected to the power input here. So, if you connect these two together, it will be the same as this part here. And then you just need to connect terminal 5 here. Since this is terminal 5, you just need to connect it like this. And on the opposite side, it's terminal 9. Terminal 9 should go to the start of the B contact. So the wire coming from terminal 9 passes through like this. And then gets connected here like this. So if you erase this part, you just need to connect it up to here like this. I've connected everything like this, except for the light part, which hasn't been connected yet. So for the lamp section, you just need to connect it separately according to the circuit. And I'm showing you that you can create the wiring diagram this way. Next is the actual diagram of the relay circuit. If you look at the left side, you can see that 220 volts AC power is coming in through L and N. Through L and N, the power passes through the NFB and is supplied to the SMPS as we know it. The power coming into the SMPS still enters as AC power through L and N. There is no polarity distinction between the line and neutral parts. However, after passing through the SMPS, the power is separated into positive and negative. So the positive power is usually indicated in red at the upper right side like this. You can see that it is laid out all the way through. Since the negative power is generally shown flowing from top to bottom, you can see that the negative power section is marked at the bottom like this. Then, just like in the circuit shown in the previous slide, the first thing it passes through is the push button. Here the push button switch is labeled as PBS. Since this is usually a start button, let's assume it is connected as a normally open no contact. You can see the part connected to terminal 14 here, and the part that connects to the negative side, which we saw earlier as terminal 13, should be connected to the relay socket, and then you can mount the relay onto it. So when you insert the relay into the relay socket and press the push button, the relay will click and operate, and we will be using the normally open no contact of that relay. So, just like before, you take one line from the positive power supply, connect it to the section shown with the dotted line, and use the no contact part. This is how you should see it. And if you look here, the connected points are number 5 and number 9. So, The part connected to number 9 is shown here with a red wire, and it's connected to the lamp. Then, if you connect one side of the lamp and connect the other side to the negative power supply, the relay operates, the no contact closes, and as a result, the lamp lights up. That's how it works. So, just like we discussed earlier in the relay circuit diagram, you can actually connect the relay lighting circuit as shown in the diagram. So if you carefully examine this wiring diagram, you'll see the relays no contact and the lamp are indicated like this, and you just need to understand that. Here, if you look at the no contacts, there are 4 of them, and you can use any one of the 4 no contacts. And you just need to indicate on the circuit diagram which terminal number you used. What you need to pay attention to here is to clearly connect the positive and negative power supplies to the relay socket pins. So if you look here, it's labeled as terminal 14 and 13, and on the actual relay, the pin numbers are marked as 14 for positive and 13 for negative. And especially for the AC power section, since the voltage is high, you need to handle it with extra caution. In our school's lab, we've designed the circuit so that students cannot come into contact with the AC power section at all to prevent any risk of electric shock. Therefore, in the SMPS section, we've installed guards so that it's completely impossible to touch the AC part by hand. And after connecting all the circuit contacts like this, it is absolutely necessary to supply power to the SNPS for the sake of safety during the experiment. I believe that conducting experiments while checking for safety like this is extremely important. By consistently following these essential safety procedures, you can effectively prevent dangerous sparks, electrical fires, or burning caused by incorrect power connections, ensuring your equipment remains safe and functional. Next, let's take another look at the actual layout of the relay circuit through an example. If you look at the left side, you'll see L and N for 220 volts. You can see that the AC power is coming in. The incoming AC power passes through the NFB and then is supplied through the SMPS. And in the SMPS, the positive power is at the top right, so it's arranged like this. Next, the negative power is indicated like this. Earlier, we saw that the lamp section can be represented in a circuit like this. The upper part needs to be connected to the AC power. So, the section marked with a dotted line is directly connected to the positive power supply. Next, after passing through the A contact, it is connected to the lamp like this. So this connected part corresponds to this section. And the lower part of the lamp is connected to the negative power supply, so it is connected to the negative power like this. We can confirm this part as well. And the section connected to the start button is now connected from the positive power supply to the start section. But here, the start button that begins with the circuit's normally open contact is not shown. So, in simple practice cases, you have to do it like this without a stop function, and if there is no stop button, we can't stop the circuit. In that case, the only option is to turn off the SMPS power supply entirely. And if you want to add a stop function, you need to reconnect the stop button here, which is a normally closed NC contact. So, you can understand that the stop button is positioned in between here. And in this way, you can see that the lamp is connected through a normally open NO contact. And in the future, when you encounter lighting sections in relay circuits, you can check the actual connections like this as a basic method. Let me say it again. If you look at the relay socket here, there are 4 normally open NO contacts. As you can see here, there are 1, 2, 3, 4 at the top. It doesn't matter which of those 4 you use. There's no problem. And regarding those 4 terminal pins on the opposite side, if you use the one on the far right at the top, then use the one on the far right at the bottom as well. Connect the normally open contacts together and then indicate that with the pin numbers. The important thing to pay attention to here is to properly connect the positive and negative power supplies and check whether the relay is working correctly. You should check those aspects as you proceed with the practice. Now moving on to something a bit more complex, I will explain the part about the self-holding circuit. You can think of it as simply adding the indicator light section on the right to the self-holding circuit I explained earlier. So to explain briefly, first, the AC power passes through the NFB and is supplied to the SMPS, and through the SMPS the positive and negative power supplies are provided. And the start button is a push button. The stop button is also configured as a push button, and typically the start button is indicated in blue. The stop button is marked in red, so it appears red. And since it doesn't operate under normal conditions but works when you press the push button, the start button usually uses a normally open no contact. And as for the stop button, since we may need to stop urgently while everything is operating well, pressing the stop button should cut off the circuit. That's why in this case we need a normally closed NC contact, so we use the NC contact part of the push button. You can understand it this way. If you look here, after passing through 90 turn A and 90 turn B, the circuit is connected to the relay's power supply. And you can see that the negative power flows out like this. And here, this is the self-hold section. You can see that in the self-hold section, a wire is taken from the top here to use with the normally open contact, A contact. And you can understand that this single wire is then connected through the A contact like this, between the non-contact and here. So with this, the left part is all finished. Now let's move on to the right part. If you look at the right part, you'll see it's drawn with long dotted lines like this. It's represented as a dashed line. This section is where the lamp is lit using the A contact of the K1 relay. And you can see that the other side is connected like this, leading to the lamp. So as you can see here in the actual diagram, thank you. Once you have finished passing through the NFB and the SMPS units, it is essential for you to understand that by utilizing a combination of two push button switches, a single relay, and one indicator lamp, you can properly configure a standard self-holding circuit so that it will operate normally and efficiently within the system. Let's move on to the next part. In this next part, I've shown the self-holding circuit using an electric relay, as I mentioned earlier, but this time only as a circuit diagram. So, unlike the previous physical diagram, here it's represented solely as a schematic, and that's what you see in this illustration. To briefly check, there's a 24-volt power supply, and the 0-volt power line is applied. Here, the start button is connected as a push button with an A contact, and then the start button is also connected as a push button with a B contact. The current that has passed through line 1 in this way flows from the positive to the negative side of the relay, so that power is supplied to the relay. This is how the relay circuit is configured. And regarding the self-holding circuit, you can understand it as follows. By using one of the relay's A contacts from the power supply and connecting it to the part between the start buttons, you create a structure where the contact is connected between the start buttons, thus forming the self-holding circuit. So the steps you need to perform first are as follows. First, connect the 24-volt power supply, then the start section, then the relay section, and finally the 0-volt connection. Try doing this first. The first case is when there is only one start button. To begin with, you can try testing the setup with just one start button, and of course make sure the relay is included in the process. For the second step, try building the circuit using both the start and stop buttons, focusing on that specific part, all the way up to the left side. Go ahead and try making that entire left section first to see how it works. Third, as indicated by the number 2 on the diagram, add the A contact part to the K1 relay and build the circuit up to that point. Once you operate it that way, the fourth step is to use the pilot lamp and another A contact of K1, specifically the A contact of K1 attached to line 3, and connect it to the plus lamp. By practicing these 4 steps in total, you can understand step by step how the self-holding circuit works. Therefore, it is very important to carry out the practice step by step. First step, second step, third step, and fourth step. At each stage, you should modify the circuit accordingly and apply the SMPS power supply so that it operates. Doing so is also very important for ensuring safety during the practice. So I believe it is very important to understand each step and to grasp how it operates. Now with the same circuit, earlier we used start and stop, but here you can see the indicated part using the set and reset buttons. Since this part is used frequently, you can understand it as essentially the same whether you use set and reset, start and stop, or start and stop in Korean. Now, looking at the circuit on the left with the start and stop buttons and the lamp, you can see how to connect it to the actual wiring diagram on the right. For example, the part that goes from 24 volts to the normally open contact corresponds to number 1 here, which goes to the normally open contact. And the part corresponding to number 2 would probably be here. Next, the part going to the lamp at number 3 becomes the third normally open contact. So here, you can see that 2 normally open contacts are being used. One here and one here. And for each of the normally open contacts used, a wire is drawn from the opposite side, utilizing the normally open contacts in this way. That's what you need to understand. And you can see that this part, which comes out through the normally open contact, is connected to the lamp like this. Next, the important part is that it is connected like this between the start switch and the stop switch. And in the same area, the other side of the normally open contact is also connected in this way. If you understand that the lower part is connected, you can consider that you have fully understood this part of the circuit. So, if you have trouble understanding, you can look at the circuit diagram on the left and the actual wiring diagram on the right to see exactly which parts are connected. Lastly, you can see that the plus and minus parts of the K1 relay are connected like this. The plus here, the minus here, each connected to pin 14 and pin 13 respectively. The terminal block is used to make connections more convenient. If you connect plus 24 volts here and connect 0 volts to the black part, you can take out each wire from here and use it as 24 volts. You can also take out each wire from the minus part and use it as 0 volts. So you can understand that the power connection terminal is used to make connections more convenient. For the relay socket part, since we usually use a 14-pin socket, you can connect the plus and minus power here and then use 4A contacts like this, one by one. Of course, if you want to use the B contact, you can connect the upper part here and use the opposite side, allowing you to use it as a B contact. You can also see that there are 4 B contacts as well. You can check how each part is configured by looking at the pin numbers shown here and the numbers on the socket. If you look at the circuit diagram, you can see whether it is normally connected or normally disconnected. In other words, whether it is in a normal open state or a normal closed state. As you know, the normal open state corresponds to the A contact. The normal closed state corresponds to the B contact. Let me summarize the content covered in the first session of week 4. First, our educational objective was to be able to explain the configuration of a self-holding circuit. And second, it was to be able to explain the operating principle. So the most important part is that we call this self-holding circuit a self-hold. And you should be able to explain how this self-hold state is maintained and how, even after releasing the button, the relay's A contact is used to keep the circuit active. And third, it is about knowing specifically how to wire the circuit so that it operates properly. With these 3 learning points, we can summarize the first session of week 4. Next, I will give you a preview of the learning content for the first session of week 5. The topic for the first session of week 5 is the new input priority circuit. This is commonly referred to as an interlock circuit, and you just need to understand how input priority is given in such circuits. And I think it's important to understand the structure of this interlock circuit along with its operating principles. This concludes the first session of week 4. Thank you for your hard work. Thank you.